Hi, welcome back. We're in lecture 17, segment 2. In this segment, we'll do a full example of a factorial ANOVA and look at the output in R. So I'm going to stick with this example that I outlined in the first segment on the effect of talking on a cell phone while driving. One of the first studies that was done on this topic was published by Strayer and Johnson in 2001. It's sort of a seminal paper that sort of set the stage for a whole line of research over the last 10 years on this topic. So they had two independent variables, remember, because we're doing a factorial ANOVA. And they tested subjects in a driving simulator looking for number of driving errors. So the two independent variables were, one, just driving difficulty. So they manipulated their driving simulator so that it was either a difficult course or an easy course. So that wasn't that interesting. What was more interesting and led to a lot more research was they manipulated the demand of the conversation. And the way they did that is they had one control group that didn't engage in any conversation, and then two talking groups. And sort of the low demand talking condition, the subject just simply had to repeat what they heard presented to them on headphones. So that's not that demanding. You just have to repeat what you hear presented to you over headphones. In the more demanding condition, the subject had to say a word that began with the letter of the word that was presented to them over the headphones. The last letter of that word, they had to generate a word that began with that letter. It was a little convoluted. So works better with an example. If they heard a word, say like ship, then they would have to say a word that began with P, like peach. And if they heard peach, then they have to say a word that begins with H, like hat, and so on. So as you can see, just in my trying to explain the procedure, that's more demanding. It's more effortful. And the question was whether conversation demand increases errors and whether conversation demand interacts with driving difficulty. So just to be clear, we have two independent variables. They're both categorical. That's why we're doing factorial ANOVA. And we have a continuous dependent variable. Again, I showed you the results already, and it looks like there is an interaction effect. So, and this is true, lots of research has supported this, that conversation demand and driving difficulty interact to produce lots of driving errors. Here's what the results look like when we go to R. So remember, we have this homogeneity of variance assumption. So the first thing we have to do before we can look at our ANOVA results is just make sure we don't violate that assumption. So here's the output of Levine's test. We did this back when we did independent T. We did it with one-way ANOVA. And it's not significant in this case. I just did that to keep things simple. In lab, it might get a little more interesting. Here's the output of the factorial ANOVA. What we get is a summary table. So first, notice that it's still just the AOV function. And we put in the dependent variable, tilde, and then the two independent variables, driving difficulty and conversation demand. Then if we use the summary function, it gives us the summary table for this factorial ANOVA. And again, it'll look the same with degrees of freedom, sums of squares, mean squares, F, and p-values. Remember, we get 3 F ratios here. And you can see they're all significant, very, very low p-values. Again, we made up the data, sort of made it this way, just so it would come out nice. You get very large F values. Again, where does the F value come from? Well, it's a ratio of mean squares. So the F value for driving difficulty is just 5782 over 61. And for conversation, 2208 over 61. And so on. And remember, mean squares is just variance. It's sums of squares over degrees of freedom. And again, always good to check your degrees of freedom. There are 2 degrees of freedom in conversation because there were 3 levels of conversation demand. There's only 1 for driving difficulty because there were just 2 levels of that. The interaction is the product of those. And if we sum them all up, it should come out to the total number of subjects in the experiment minus 1. Now, we have a significant interaction here, so we have to follow that up with what's called simple effects analysis. So just like in a one-way ANOVA, if we had a significant main effect, we would have to follow that up with post-hoc tests like Tukey's. When you get a significant interaction, you might want to engage in simple effects analysis. And you can do this one of two ways. You could do the simple effect of A at each level of B, or the simple effect of B at each level of A. You should just pick one and not do both. That would be redundant. So just pick one that tells the story the best. So if I look at the output and I look at this bar plot, to me it makes most sense to do the simple effect of the driving difficulty at each level of conversation demand. That way I can just do a series of t-tests. So that's a really simple effects analysis. So that's what I did in R, is I just did a series of t-tests. And what I did first was I looked to see if the driving difficulty manipulation had a significant effect when there was no conversation. So just when there's control group, no conversation, did their driving difficulty manipulation have an effect? It had slightly an effect. So if you look down at the Cohen's d, it's 0.47. But if you look at the p-value, it's not significant. So if we go back and look at this bar plot, what that's saying is this comparison right here is not statistically significant. If we go to the talking conditions, so this is the easy talking condition, now we get a nice low p-value, really large Cohen's d of 2. That's a really large effect size. That means there's 2 standard deviations more errors when people are in the difficult driving simulator relative to the easy. So if we go back to the bar plot, this difference here is clearly significant. Finally, go to the high conversation demand condition, and the effect gets even bigger. All right, look at the Cohen's d, it's now 2.8. Obviously, p is going to be less than 0.05. That's a really significant simple effect. Again, it's the simple effect of driving difficulty at a particular level of conversation demand. And that's how I explained where the interaction is coming from. Is, to wrap up this segment, is I showed you the bar plot, and then I showed you the output from R showing you F ratios that were all significant. Most importantly, the one associated with the interaction. Why is there an interaction? Well, because the simple effect of driving difficulty is not significant in the control condition, but it is significant in the 2 talking conditions, and the effect gets larger as conversation demand gets more difficult. So again, these 2 variables interact to produce more errors in the driving simulator.